Last time on Transistors, we took a look at our OR gate. We saw how, if you use NPN and PNP transistors, how different the two circuits actually looked. Today, we're going to do the same for our AND gates. And yeah, in fact, seeing as that I just mentioned this, can you imagine how these two circuits will be different? Well, keep that picture in mind and we'll see if that's correct. Hello and welcome back to Transistors. Now, quick recap on what the AND gate is. If we say X and Y must be true, then of course, both have to be true for the whole statement to be true. That is exactly what's happening in the truth table here. The only time in which, the final output is actually true is when both of the inputs are true. At any point of time, as long as one is false, the final result must be false. And with that truth table in mind, let's proceed into our circuit design. So let us start with a simulation of our AND gate using NPN transistors. This time the NPN version is the simpler of the two, and yeah, it's essentially just two switches in series. As usual, I'm going to start with our pull down disconnected first so you can see what actually is happening. As long as our base is 0, our switch is open. As a result, the high state is not able to flow through to our output. And basically, if you were to switch just one on, you can never have the high state actually flow all the way through. The only way to get it to go there is to have both inputs at the high state. So at all other times, the output is going to be, in the floating state, disconnected. And that's why we connect our pull down resistor to pull its value to 0. So that's basically the idea. Let's now take a look at the schematic. As always, we will begin our schematic with our power rails. Then we bring in our transistors, which are just, exactly what you have seen, two NPN transistors in series with the output pulled down to low. Then we bring in our switches and we connect them through current limiting resistors to the two bases. Of course, we want to see the result, and the result manifests at this side, which is why we're going to go ahead and add in our LED at this position. Basically, as long as any one of the switches are open, what that means is, there is no connection between sort of this point and our high state. So we can visualize it like this, It's essentially just this circuit on its own. Of course, the positive terminal is going to get pulled down low, and our LED will not be lit. Now, if we were to actually push down our switches, then something different happens, Both of these now become, closed circuits, and as a result, our high state is able to flow through and light up our LED, giving us our high output. So that's as simple as it gets. Let's go ahead and see the result in action. Alright, here is our AND gate using two NPN transistors. Now, because we are setting these two up to sort of work in series here, we have them side by side, And the emitter pin of the first transistor is connected to the collector pin of the second transistor. And that happens because they're using the same column. So now, pressing any button on its own will not light up the LED. But if I were to press down both, the LED comes on. So as long as I hold down both switches, the LED will come on. Zooming in on the two transistors, you'll see they're basically connected as I've described, These, of course, are our two resistors connecting our two bases. And what that means is the column in the center here is the column in which these two transistors share the same pin. Of course, our high state is coming into the collector here, and from the emitter of the second transistor, we are going back to ground via this pull down resistor. At the same time, our LED is also sharing this column, which is why, when both bases go high, our LED will light up through that output, like so. So there you go, that is an AND gate using NPN transistors. I really hope you're getting some kind of deja vu over here, because that's essentially what's happening in this episode, Every sort of circuit we're seeing here is just a reversal of what we've seen in our previous episode for the OR gates. Now, we're trying to build an AND gate with PNP transistors. And as it turns out, we're going to need to have these two in parallel. Again, we're going to disconnect our pull-up resistor and we'll see how this works. Essentially, as long as any one of these inputs are low, the switch is actually closed and it allows our low state, our ground, to flow through to the output. However, when both inputs are high, then both switches are open, and as a result, our output is now floating. So yeah, to get a 1 here, we simply go ahead and pull it up high, and that is our AND gate. As long as any one of the inputs are actually 0, the ground is going to come over and overwhelm our high state, which is pulled up. Otherwise, well, the high state prevails, and we get our high output. Let's see the schematic. Again, much deja vu here, right? We're going to start with our power rails as usual. We're going to bring in our transistors, which are now connected in parallel. Of course, note that the pull-up is now on the high side. We bring in our buttons, we connect our buttons to the two bases through current limiting resistors. And yeah, don't forget now that, well, because we're working with PNP, the results LED is going to be connected here on the so-called high side, right? The side that's actually being pulled. So hopefully you can sort of see the pattern. Let's see how this whole circuit actually works. With any one of our inputs open, what's going to happen is, well, assuming this one is closed, but this one is open, then essentially, well, our ground is still able to flow through this way, right? Through this one, which is still closed. This ground is going to come through, it's going to override our pull-up resistor, and as a result, the positive terminal of our LED is going to go down to ground. Of course, it will not light up in this stage. However, if we were to close both switches, you will see that, well, it's equivalent to disconnecting these two lines. Since there is no direct connection to ground now, well, our pull-up resistor is all there is. And as a result, our high state is able to flow and actually light up our LED. Yeah, I think, you should have a pretty good picture of what's happening at this point. Let us jump into our breadboard. So here is our PNP setup. So this of course looks exactly like our NPN OR gate from last week, but of course this time it is an AND gate. Now notice how, pressing each individual switch does nothing. But if I were to hold one down and the other, now the LED lights up. To look closer at our setup here, well, of course we have our two transistors, and yeah, they're all actually fed by this very busy column over here. Basically, this column is connected to our voltage source through the resistor here, and that is feeding our LED, as well as our two emitters, which are here. The bases are of course connected to the two push buttons, and yeah, the outputs go straight to ground, in accordance to our schematic. So yeah, with something like this, we have our AND gate that requires both buttons to be pressed down before the LED will actually light. And there you go. Interesting how the AND gate and the OR gate actually sort of mirrors each other, but sort of in an opposite way when it comes to actually laying out our transistors. But yeah, that's how the AND gate actually works. That's all there is for this episode of Transistors. Thank you very much for watching, and until next time, you're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.